students, today we will be talking about matter and its three states. Before we go to these three states of matter, let us understand what is matter first. Anything in this world is made of matter. It's made of something and that something is matter. So this pen, water, your school bag, your books, air around you, everything is made up of matter. There are two properties of matter. Matter takes up space and it has mass. What do you mean by takes up space? You must have heard of some term called volume. This space that matter takes up is known as volume. So everything has a volume. This pen has a volume. Anything that is 3D in shape has volume. Something that has length, that has breadth and that has width. Anything 3D has volume. So if I take this jar and pour water in it, then I can say up to this level. So you'll ask me, what is the volume of water that you have poured into this container? Matter also has mass. Everything around you has mass. Then what are these three states of matter? So matter comes in three states. All of you know those: solids, liquids and gases. Do these three have their own properties? Yes. There are some properties that distinguish solids from liquids and gases, and liquids from solids and gases the same way. What are these properties? Let us talk of solids first. If I take this duster, it is solid. It is something you will say inadvertently, this is solid. Why is this solid? Because this has a definite shape. You cannot change the shape in any way. If I take this duster and try to put it in this bottle, will the shape change? No. It has definite volume. It has definite shape and definite volume. So this is solid. What about liquids? What are the properties of liquids? Again, let's talk about this container. Liquids definitely have weight. They have mass. And they definitely have a definite volume. But what about its shape? Have you seen water in one particular shape? Think? Of course not. I have water in this container and the water has taken the shape of this container. I'll take the other container now, the bigger one. Let's see what happens. So this we know already. Water took the shape of this bigger container now. So liquids do not have any particular shape. What about gases? You can see solids and liquids. What about gases? Gaseous state you cannot even see. The air around you is in gaseous state. Gases do not have a definite volume and do not have a definite shape. You say this container is empty, right? That is because you cannot see anything into it. But there is definitely air that is taking up this space. Let us understand what is definite volume and definite shape of any object or any state of matter using the compression technique. If I take this black stud and try to push inside, will it change its shape? It will of course not. You'll be like, it does not. Why will it? Because it is a solid, it has a definite shape, it has definite volume. The volume is not going to change. If I take water, water does change its shape, but it has a definite volume. And gases do not have a definite shape, neither do they have a definite volume. So let us start with the activities which will make this concept even more clear. For this compression technique, we are going to need this syringe. You must have seen the syringe at the doctor's place when you go to take an injection from the doctor. This is the body of the syringe and this is the plunger. So pull out the plunger. First we'll be talking about solids. So take this black stud from the kit and pass it through the body, in the body of the syringe. And just try to press this against the syringe. What do you think? This does not get pressed. After a limit, you cannot change the shape of the solid. It has a definite shape and a definite volume. You cannot increase or decrease the shape, make it smaller. So, this cannot be compressed. What about liquids? So, first of all, we'll put this stud aside. Bring the plunger to 0 position. Pass the syringe into a jar of water and gently start pulling the plunger. Now you have to make sure that the tip of the syringe is completely dipped in water while you are taking water from this jar. Now we cannot press it as it is because water will come out. We have to close the mouth of the syringe using the finger. I will not hold it like this, otherwise you won't be able to see it. So hold it tightly and press. Can you press it? Like, no. However hard I try, I cannot change the volume of this water. It cannot be compressed. Shape, okay, the water has taken the shape of the syringe now, but cannot be compressed. Now for gaseous state, we are going to use this dhoop stick that has been lit up. You can see smoke coming out of it. You will ask your parents to give you this dhoop stick. You need your parents' help for this basically. Take out the plunger. Here you will first have to cover the mouth of the syringe and fill this syringe with smoke. And put the plunger on it. Now try to, without removing your finger, try to push. It easily gets pushed. So that shows gaseous state does not have any particular or a definite volume. Also, it does not have a definite shape. Children, now we are going to do a simple but a quite confusing activity. Why confusing? Let me tell you. See, we worked with this stud and we said that when we put it inside the syringe and apply force, you cannot compress a solid. It's not possible. But is it true always? I've taken this foam piece and I am going to put it inside the syringe and put the plunger from top and apply force on one side. Now just see what happens. Oh my God, what just happened? The foam easily got compressed? How is that possible? What is happening? Let me tell you what is happening. If you look at this foam, or say for example this foam is of course a solid. It is not a gas to get compressed, but this foam has a lot of porous space in between. So this porous space is occupied by air. When I am putting the foam inside the syringe and pressing it, the air is getting pumped out from these pores, and that is why we feel that this foam is getting compressed. This is not the case here. There is no porous structure where air can go and sit. That is why we feel that this does not compress and this does compress. Basically, we are not compressing the foam. We are just taking out the extra air that is sitting in the porous structure. We know now that we are just pumping out this air out of the porous structure. Let me show this to you once again. I'm pressing the plunger and look at this. This is a more dense material now because all the air has come out. You can also try this with a sponge. Soak the sponge in water because we cannot see air coming out. What we can do is take sponge, soak it in water, then put it in this syringe and put the plunger and press it. What will happen is water will come out of this tip. The water that had taken the porous space inside that solid. So this is how this activity is done. Do try it.